So, this continuation of the previous topic discussion, there is a motion in a magnetic field. The previous class ends here. There is a diagram, and there is a charge placed on uniform magnetic field. What will happen? Actually, charge now there is a rotation, okay, and there is a force. It is called centripetal force. Okay, when a charge placed in a uniform magnetic field, this will happen actually. So there is a force, and that force, the magnetic force, that is equal to Q VB. Okay, that is a V cross B. There is a cross product, and B and B, they are perpendicular to each other, so there is a sine 90 degree. So sine 91. So Q VB sine 90 degree. So sine 90 get 1. So Q VB. That's the equation number 1. And from that Newton's law, okay, there is a force, okay, from that's the force equal to mv square r, and this force obviously that is equal to, for mechanics, mv square by r, the radius. That's the equation number 2. And now these two equations are the same equation, that is 1 equal to 2, and we get qvb equal to mv square by r. That's the velocity. Okay, so now these b and this are the cancel, so that is qb equal to mv by r. So the radius of that given circle here, so that's why r equal to mv by q times b. Okay, that's the radius. Now let's give the equation number 3. Clear? And here you see that the m times v, that is mass times velocity, we get momentum. Of charged particle. Charged particle. That's very important. Okay, so here that's the velocity, so that there is a kinetic energy obviously. Now there is a kinetic energy, that is, suppose from the energy, that is equal to half m v square, and that energy, and here the charge q, suppose there is a charge q here, okay, the charge q, the photons, positive charge, so there is a related to potential. Okay, we know that is energy U equal to Q times V, and we know that. Okay, and now that energy equal to QV, so that energy equal to Q charge times potential V. The V is the potential. Okay, so now that the V square, okay, replaced by from here, so V equal to qbr by m, qbr by m. Okay, so now the v replaced by half m qbr by m whole square qb, that the v is the potential. So capital V represent the potential and the small v represent velocity. Okay, clear the notation. Do not confuse the capital V and small v. Now that is half, and we get there is another expression, that is m qbr square by m square. These m and square cancel, qv, and we get final expression of r, that is a qbr square, that is equal to 2mqv. Okay, and there is the final expression of r, that is 2mqv by q square b square root, and these q's are cancel, So we get final R equal to 2mv, that's the potential, by q b square root. That's the final expression of R. Okay, clear? There is a root term and there is a R. Okay, these R square is directly proportional to potential V. That's very important. Okay, remember that. So we get R, and R is that the radius R. So we find that expression of R here is that expression of R, radius of that circle we find here. Now there is a rotation. Obviously there is a rotation, and how the rotate? There is a helical helical structure actually. So now there is a 3D Y. There's the 3D diagram X, and there is a Z. Okay, so how the helical structure, how the actually not, that's the face. Okay, that's the diagram, and actually there is 3D diagram. I try to draw that diagram. Obviously there is a 3D diagram here, 3-dimensional diagram. There is a positive charge. Okay, suppose there is a photon. Okay, suppose that the photon here, and there is a magnetic field in that direction, B, in that direction. Okay, direction on x-axis, parallel to x-axis, B. So now that structure look like this. Try to draw 3D diagram actually. The dot helical structure. Now when get front, there's a dot means backside. Okay. Okay. Clear? That's the direction actually. And now suppose consider there is a velocity here. Suppose there's a velocity here. So there's a tangentially present velocity, and there's a perpendicular to magnetic field or x-axis. So that's the velocity perpendicular component. And there is another component of velocity. There's a parallel to x-axis or parallel to B. So that represents V parallel, because the V parallel is parallel with the magnetic field or x-axis. So B actually that's the x-axis, B in that axis. Okay. So now that very important, that's that actual diagram is look like this. So now the radius is, suppose there's a center point. Suppose that's R. That R equal to, here we find here R. That's the final expression of R. Now, when they rotate here, there is a time period. There is time period T, that is equal to, you know that is a 2 pi R by V velocity. So now 2 pi by V, and here the R is replaced by from this expression, from 3, R replaced from 3, from equation 3. Okay, from equation 3 we get mv by qb, and these we cancel. So we get time period T, that is equal to 2 pi m by q times b. That's a time period. Yet second. Now we find the time period. Okay, so there is a frequency. There is a angular frequency. Angular frequency omega, that is equal to 2 pi f linear frequency, and that is equal to 2 pi by t, because we know that f equal to 1 by time period, frequency equal to linear frequency equal to. So now that omega, that is equal to 2 pi by t, t here 2 pi m by qb. Now 2 pi cancel, that is qb by m, that is equal to W omega, the angular frequency. Okay, that's a very important how to find the angular frequency, because the charged particle rotate in helical structure. Okay, there's a charged particle actually look like a helical motion. I see actually we draw here the front view. Okay, previous class we draw that the front view. That's the front view. Okay. Now another important term here is a mathematical term. If it to that length actually when that's the length, this length. Okay, this length is called pitch. This length is called pitch. Okay, pitch. So pitch is, what is the pitch? Pitch is the distance moved along the magnetic field in one rotation is called pitch. There is a one rotation of magnetic field is called pitch. So now the pitch equal to P, that is the distance. So here the distance means, so pitch in that velocity parallel line. So velocity parallel, the length, velocity time, velocity parallel multiplied by time period. So that's the T. So velocity parallel, time period equal to find 2 pi m by qb, 2 pi m by qb. So finally pitch equal to 2 pi m v parallel by qb. That's a pitch. Okay. The distance moved. Suppose that define the pitch here. Suppose define pitch for 1 marks question. What is pitch? The distance move along. The distance move along the magnetic field. The magnetic field in one rotation. In one rotation is called pitch. Okay, clear? Now here we discuss the another important concept is called cyclotron. It's very important. Okay. Cyclotron. Cyclotron is a machine or a device for accelerating the charged particle. So cyclotron accelerating charged particle. And that's a very important concept. Cyclotron is that device to accelerating the charged particle. So that's the two conducting discs or a metal plate here. Two conducting discs. Not like that. Okay, there are two conducting discs, and here is a magnetic field B out of the board and towards me. Now release a proton from here. Proton from here with the velocity v. Okay, so proton has the energy, suppose 1 kilo electron volt, the proton energy. Okay, now the velocity in that direction, so magnetic field is out of the board, so that is F equal to q v cross b. So v cross b, so force is downward, so the direction is in that direction. So now there is a circular path. Direction is a circular path in here. Now, very important. So that's the high potential. Suppose here applied the 20 suppose volt potential difference applied here, these two D's. So there's the high potential, there's the low potential. Now generate an electric field in that direction. So now that's why this photon moves here, and that's the electric field. When photon goes here, so gain some energy. So now the energy is 1 kilo electron volt plus 20 volt. So here kilo means 1000 plus 20. So that means 1.02 kilo electron volt. So the energy is higher. So now check that. Suppose there is a battery supply, there is a plate, here is a positive plate, and there is a negative plate here, and that a proton move in that direction. So the potential is Q times V, the potential, that is equal to half m v square, that is equal to energy U, or suppose that the kinetic energy of this is equal to K or U. So that if energy is higher, okay, so that's the important is that if energy is higher, okay, so means the velocity means higher, so velocity is increases. So here the velocity v, some part at that point the velocity is increasing, and these two are metal D's, the D's, and these are conducting metals, okay. So see that if that velocity means higher, so radius will be higher, r. So now the radius is increases. So radius is increasing. Now okay, at that point. Now they flip that portion. Okay, the batteries flip that. Now that's the high potential, that's the low potential. Due to this, there is a generating electric field in that direction. Electric field, and these proton are jump from here to there at that point here. Now here is again some energy. So suppose 20 volt supply here. So that's the 1.02 plus 20. So we finally get 1.04 kilo electron volt. Again that same formula, radius will be higher because R equal to mv by qb. So put here R equal to mv by qb. So velocity is higher, so radius will be higher. So the energy obviously higher. Okay, velocity is higher, so energy obviously higher. So now there is some rotation. When one rotation, they gain the energy. So photon gain the velocity. Okay, they gain that velocity, and that's the gain the energy. So that's the potential. So here, so not velocity is decreased. So now I flip that portion. Now there is a high potential being a low potential. Next step, so that's a high, that's a low. Again the back to this, so that's again some energy. When there is a call 1000, 2000, 3000, 4000 rotation, the more rotation means more air speed. So more rotation, more full cycle rotation, okay, gain velocity. If velocity is gain, so energy gain, energy gain. So we just flip that portion. Now we put a AC oscillator here. They just flip automatically. They flip that oscillator AC source. Okay, they flip that portion, and that oscillator they just flip that portion and just flip to gain the energy. Suppose we gain the kilovolt to megavolt, just to flip that portion. We now not put extra energy here. We flip that portion, automatically this proton charged particle gain energy. And suppose there is a releasing point, suppose there is 1000 rotation from releasing the rotation here, rotation, 1000 rotation, again leave that. When leave that from these, the exit point, so gains a high speed, high velocity, high speed, charged particle gains high speed and high energy also. And these charged particles strike another charged particle. Okay, that's very important in concept of the atomic bomb structure. Okay, when the high particles strike the uranium and now the uranium is break. Okay, that's means a fission reaction actually. Okay, there's a fission reaction. There's a strike that the high charged particles strike to uranium and the uranium break into that two uranium and these two uranium, then starting the chain reaction. That's why these high energy and high speed charged particle photon is very important. Okay, to fission reaction, uranium fission reaction. But that's a very important concept. So that's why that velocity increases, so radius obviously increases. That's the important concept here, and that is also equal to the radius increases, so potential increases, so potential related to that energy actually qv, and that's the energy obviously increases. So mainly cyclotron is the purpose that's for use the bombarded nuclei with energetic particles so accelerated by it. So cyclotron is used, mainly they use that, mainly they use is cyclotron used to bombard nuclei with energetic particle so accelerated by it. Okay, that's very important. Another few times we discuss how the cyclotron is very important for making an uranium fission reaction. Okay, not fusion here. That's the uranium fission reaction. That's a chain reaction uranium. That's very important. On a pre-lecture, we discuss that cyclotron and uranium fission reaction, how to that convert a atomic bomb. Okay, so that's a free class, right? Not here discussion in our board syllabus here. Okay, there's a free time to discuss that. So how clear the what is a cyclotron and why the accelerating charge particle is very important to making that uranium chain reaction. Okay, uranium chain fission reaction. The bombard these of the particles, the bombard the uranium and uranium will break. Then the uranium break and the chain reaction will be started. That's important. Okay, so concept clear how the cyclotron is very important, and if any doubt in that portion, always ask in comment section. I will try to give the answer. Next class we discuss the new topic, new concept. So today in the class here, thank you.